Yep. Anybody get an answer here? Want to share? Want to say, I think it's 8 pi. Oh, now a lot of people agree. Yeah, so if you're looking at the pictures, it's mostly all set up for you. We just need to go through and do it. This one, we have to rotate around the x-axis, not around the y-axis. So you can see in the picture the orientation of the cylinders. They're kind of laid on their side instead of standing up on end now. So as you see in the picture, the shell radius is going to be y. The shell height is going to be 4 minus y squared. How do we get that? You don't have any clue? Well, the first thing we need to do is make this all functions of y, right? And so we have here, we need to change y equals square root of x, which is our function. We need to change that into x equals y squared. And we're not looking for, you know, if we were looking for, give me a color. If we were looking for like this part of it, if we were to revolve like that around and have like a empty bowl kind of a thing, you know what I'm talking about? Like we had the area we're looking for cut out of it. If we were doing that, then we'd just use the y squared, right? We would say, okay, this works. This is our height right here. But we're not interested in that height, are we? We're interested instead in this height up here. And so we know that this whole length is 4, right? I'll zoom in on that. That whole length is 4. This length right here is y squared. So this has to be 4 minus y squared, right? That's 4. That's y squared. You see that now? Make sense? So now that's why it's 4 minus y squared, okay? So then that's what we have right there. So that's what our height is, 4 minus y squared. What else do we need here? So if we're doing the volume, I just got to write this out. Volume of a cylinder, we're going to add up. Volume of the cylinder, we want 2 pi times the radius times the height times the thickness, right? So this is going to be sum, and then we're summing over dy, right? So what are our limits of integration going to be? Yeah, because that's just what y goes from, right? 0 to 2, literally 0 out to 2, the minimum y to the maximum. So 0 to 2. We can bring our 2 pi out front. Our radius, we just said, was our function, which is just, or not our function, but our actual y value that we get out of it, right? So it's just going to be y. And then our height is our function, essentially our two functions, like the difference of our functions, essentially. So this is going to be like, how do I put that? It's like f1 of y minus f2 of y. If, you know, this is x equals 4, this one's x equals y squared. So it's like the, you know what I mean? Like if this is function f of y1 and this is f of y2, you see what I'm saying? It's the difference between those. It's f of 1, or maybe I should have put the 1 on the inside there. This should have been, so this line here is x equals 4, which is f1 of y. And this is f2 of y. Am I making this more complicated than y'all need it to be, or is it good when I show y'all this? If you're like algorithmic, you probably don't like me the way I do these, huh? If you just want to memorize an algorithm and do it every time, then that's just not me. I cannot do that. And I always think that I've misremembered the algorithm anyway. So I tend to think everything through from start to finish whenever I do these. It makes me kind of a slow test taker, but it also makes me get pretty good grades typically. So, all right, so that's where I was on. So that was R. And then That's, no. That's R, that's H, and then dy is our thickness. Okay, there we go. Yep, so that's what we have to do, which will then become, 0 to 2 pi, 0 to 2, y times, and then we're going to do 4 minus y squared dy, which will be 2 pi integral 0 to 2 of 4y minus y cubed dy. Looking good so far? And then this becomes 2 pi times 4y becomes 2y squared minus y to the 4th over 4 from 0 to 2. And then we can plug in 2, so this becomes 2 pi, and then we've got 2 squared times 2 is 8, minus 2 times 2 times 2 times 2 divided by 4, which is 4. And then, sorry, if you want this here, then minus 0, like that, right? We'll plug the zeros in. And so we have 8 minus 4, which is, anybody? 4. And then 4 times 2 is, anybody? 8. And then 8 times pi is 8 pi. Good. Woohoo. Yeah, if you don't like the way I do these, you can feel free to just use the algorithms. But I really think it's a good skill to be able to do this, because this is how this stuff gets, these people came up with these things, is by thinking it through this way. So, you know, if you're doing math with the intention of just being able to do whatever math already exists, then you can, I guess, just memorize as much as you can. But I am the one that thinks that memory fades and understanding stays. So that's what I usually go for. And I don't have the greatest memory. I don't trust it anyway. So, okay. Any questions on that one? No, we feel pretty good. Okay. So let's go over here to this next page. Summary of the shell method. So I don't need to read all this to you, but you're essentially going to draw it, sketch it, figure out how you're rotating it, find all your limits, and then put it into our volume of a cylindrical shell, right? 2 pi RH times the thickness dy. Okay? And that's it. You just find in the volume of like a thin cylinder shell, like the thickness, like if it was just the walls of a Coke can, finding that real thin thickness. Okay? Yeah. All right, so what I'm going to do is, I've got a couple problems for y'all to try. Really, it's the same problem, but we're going to revolve it around 2 different axes. So we're going to do this one. So this, we want to find the volume of the solid generated by revolving the region enclosed by the graphs of y equals e to the negative x squared. Anybody know what shape that is? Oh, you're gonna have to think about that one. Y'all should know this one. Y equals 0, x equals 0, x equals 1, and it's revolved about the x-axis. And so the first thing I want you to do is try this with disk. That was 6.1. And then try it with shell and see what happens. So start with disk. And then after that one, try shell for the same one, okay? Anybody know what that e to the negative x squared looks like? Well, we know when x is 0, this is what? 1. So we can at least say that. What happens as x gets bigger? Gets smaller, right? Because this is really 1 over e to the x squared, right? This is 1 over e to the x squared. And so as x gets bigger, then x squared gets bigger, which makes the denominator bigger, which makes us smaller. So as we go out to infinity, we've got to go toward 0. What about as x goes negative toward infinity? Samesies, right? Because we're squaring it. So it's going to go back to being so it's going to do that. Anybody figured out what this shape is yet? Starts with a G. Gahil. It's Gaussian. Y'all don't know the. Oh, okay. All right. It's that shape. Really?